Check one. Hello, everyone. All those are standing outside the auditorium are requested to take their seat in the auditorium. We are going to start with a special expert lecture talk. I once again request all standing outside the auditorium to take their seat inside the auditorium as early as possible. Ladies and gentlemen, esteemed guests and distinguished speakers, a very warm welcome to the special lecture series session of the 30th National Convention of Mechanical Engineering and National Seminar. I am Dr. Meera Dhabu, and it is my great honor to be your host for this enlightening session. We are truly privileged to have you all here today, and I extend a heartfelt welcome to each one of you. Our special lecture series session today, featuring two eminent speakers who will share their profile insights with us, promises to be an intellectually stimulating experience to all of us. Before we dive into the rich content that awaits us, let me briefly set the stage for this session. Our first speaker for today is the distinguished Professor Milind Atre, the INOX Chair Professor at the Indian Institute of Technology, Bombay. I take this opportunity to congratulate Professor Atre, a recipient of Eminent Engineer Award today. Professor Atre will be delivering the Dr. S.C. Bhattacharya Memorial Lecture 2023 on the role of AI and ML in mechanical engineering. Artificial intelligence and machine learning are not just a buzzword. They are transforming the way we design, analyze, and optimize mechanical engineering system. Professor Atre's expertise in this domain promises to shed light on the transformative power of AI and machine learning in mechanical engineering field. Following Professor Atre's lecture, we have the privilege of hearing from our second esteemed speaker, Professor R.P. Mohanty, the former Vice Chancellor of SOA University Bhubaneswar. Professor Mohanty will be delivering the State of the Art Lecture 2023, focusing on future of mechanical engineering. His insight into the exciting prospects and challenges that lies ahead in mechanical engineering field are sure to be enlightening. Now, I request Dr. N.T. Rangareddy, Chairman MCDB IEI, to welcome our first guest speaker, Professor Milind Atre. I request Mr. Milind Pathak to join. Reddy, sir. Thank you for gracing us with your presence, Professor Atre. Now, allow me to introduce Professor Milind Atre to our esteemed audience. Professor Milind Atre is an eminent figure in mechanical engineering and the INOX Chair Professor of Cryogenics at IIT Bombay. With a PhD in cryogenics from IIT Bombay, Professor Atre has excelled in various leadership roles, including Dean R&D and Professor in charge of Society for Innovation and Entrepreneurship, popularly known as SIGN, which is an umbrella organization at IIT Bombay for fostering entrepreneurship and nurturing tech startups. His academic journey began at VNIT Nagpur, followed by postdoctoral research in Germany. Professor Atre's pioneering work in indigenous cryogenic system at Raja Ramanna Center for Advanced Technology Indore and subsequent contribution in MRI and NMRI system, cryogenic heat exchanger, and superconducting devices have been globally recognized. As a fellow of Institution of Mechanical Engineers and FICC and founding chair of Institution of Mechanical Engineers Process Industry Division, Professor Atray's impact extended worldwide. He holds membership in the International Cryogenic Energy Committee and advises on the editorial board of cryogenic journals. With over 150 international publications and 5 patents, his contributions are substantial. Notably, his innovative approach during the COVID-19 pandemic converted nitrogen generator to oxygen generator, benefiting in converting numerous machines for patients in need of oxygen in India. Recipient of the Professor Sukhatme Award, Dr. Patwardhan Technology Development Award, and the Industrial Impact Award, Professor Atray's influence span academia and industry. He advises on projects in defense, space, and atomic energy application, contributing to advancements in cryogenic heat exchanger, cryocoolers, data center cooling, cryosurgery, heat pipe, and superconducting devices. Professor Atre is a luminary in the field of mechanical engineering, renowned for his contribution to research and education. With extensive experience and expertise, he is the perfect choice to dwell into the topic of AI and ML in mechanical engineering. We now kindly invite Professor Milind Atre, our distinguished speaker for the Dr. S.C. Bhattacharya Memorial Lecture 2023. I request all to welcome him with a big applause.
Thank you. I'm okay. Yeah. So good morning, or should I say good afternoon now. And thank you, Dr. Meera, for kindly introducing me here. This page reminds me of some 6 years back when our own director, Dr. Padole, bestowed me the Distinguished Alumnus Award from VNIT at the hands of Dr. Kakodkar. And I think Mr. Gadkari also was there then. So a lot of memories of this place and of course a lot of memory of this institute. And that's why I put these two buildings who have really influenced me from doing my work from mechanical engineering, VNIT Nagpur and IIT Bombay. So this is the very place from where I started the ABC of mechanical engineering and still continuing to possibly learn the D and E and F of the mechanical engineering. So my talk is on AI and ML, the artificial intelligence and machine learning, which many of my generation believe that this is not for us. And I'm sure many amongst you also may believe that this is not meant for mechanical engineers and this is meant for somebody else. But it's very important that mechanical engineers realize that this is meant for all of us, not only for mechanical engineers, but it's possibly for every engineers to understand if you want to do research and further innovations and collaborations in the same field that we are working. So my talk will be around these lines. And because I'm short of some time, I will go a little faster. So many of us believed, and today we all believe, that mechanical engineers are in these silos. We say, I'm a design MTech, I'm a thermal engineer, I should not understand anything from design. Well, that the same person says that, why should I know manufacturing? Why should I believe the copper and stainless steel should be brazed together? And why should I do silver brazing? What is the leak rate? All these parameters are very important, but we have ourselves created these silos. And in these silos, no system can be developed. We can possibly worry about temperatures, the stresses, manufacturing independently. But if I want to develop a system, if I want to develop a product, if I want to develop a technology, as a mechanical engineer, I should be aware of all these three things. But the problem is here that we blame the others and the problem starts. However, this is a very important thing that today we have to learn, that the real research and the interest lies in this interface. The interface of thermal to manufacturing, thermal to design, and this is where the exciting opportunities are there. And the industry, I'm sure many of this will approve that the industries will say, I have to know about everything. I have to know about all these three things. Then only my product will be ready. So many of us believe is this the existential crisis today for mechanical engineers. Let me tell you a small episode. Just now we had admissions at IIT Bombay, and I was as a senior professor addressing to all the first year students of mechanical engineers. And let me tell you, at IIT Bombay, we have stopped change of branch. So right in the first year, whatever branch you get, we don't let them change. So this crisis of change of branch from mechanical to computer science and everything has been stopped completely. So those who have come to mechanical department, they have to understand that this is it. You have to be loyal to this branch. So when I talked to these students, and there were almost 200 students, we have got a BTech and dual degree student, and I asked them, how many of you wanted to come to IIT Bombay as a first choice? And almost everybody raised their hand. Almost everybody. They were all toppers and possibly first 500 all India ranks. And then I asked, how many of you wanted to be mechanical engineer? Some people like this, some people like this, and maybe 15 or 20 raised their hand. And then the crux of the matter is here that in our time, everybody wanted to be mechanical engineer or electrical engineer. But now that hand, which was like this, has possibly come halfway down. And slowly, if we don't wake up, this may go down also. But then I also asked the next question: how many of you would like to work on artificial intelligence and machine learning in mechanical department? And almost everybody, like both hands, went up. Well, friends, I think that is the story. Everybody knows at 12th standard that mechanical engineering changing. The basic never changes, the core remains the same. The techniques are changing. Same thing happened to us when we had to learn computer language. Maybe we started with Fortran and then C++. We wanted to learn why computer science people should learn these languages. But now almost everybody does coding. Same thing happened when data acquisition system came, microprocessors came, electronics came, and we said, no, we don't have to worry about that. Let me tell you, not a single system will be ready today unless I know about electrical engineering, I know about controls, I know about mechanical engineering, and a bit of software. I have to know these things if I want to come with a product. So this is it, that we don't have any existential crisis because the machines are there. But I believe we got an exciting opportunity. So all of us have an exciting opportunity provided all of us are who are seniors here wake up to the call and excite the youngsters to see that there's a huge possibility of doing mechanical engineering at the interface. And this is the interface that right now we are at. This is the excitement is there at the interface now. When I'm talking about thermal, I have to learn, manufacturing, I have to learn, design, I have to learn. In the same way, I have to learn all these things. A mechanical engineer has to learn about mathematics, controls. Today, biology, healthcare is a very, very important thing. All the healthcare equipment are coming from mechanical engineers. Metallurgy, material science, nothing can be possible today unless we know material science, unless I understand the machining aspect related to material science. Electronics engineering, electrical engineering, of course, bread and butter for us. My machines will not get started unless I got a very optimized power supply. All right. Aero is, I think, the brother sister relationship between aero and mechanical. I also say, and computer science, software. I have to know these things, and the next interface is now the AI and ML. So artificial intelligence and machine learning is the next interface that all of us have. Unless we learn, and even at this age now, I've started learning this, and I've actually started implementing this in my laboratory. I have to learn from my basics, but I've got good students. So many of you have got good students. So many of you have got good PhD student, MTech student, but industries, unless they filled in right now, unless they impart training right now, AI ML is the only solution to go ahead. I'll say right now. So very exciting opportunities. If I am having a startup or an industry, my engineers will be sort of worked up to do the same job again and again. AI ML helps you in solving out those things. So my next talk now, I'll talk about opportunities for all of us, and then further come out with a. We had Chandrayaan. Chandrayaan was not possible unless we had AI ML embedded into it. If I want to stop my car in a parking, I take my car, I go to the parking and find that road is not good. I will go to somewhere else. If that is not good, because I may not be able to reverse my car to take my car out, I will find some other place. What happened? The rover did the same thing. Nobody told the rover itself knew that if I want to land up here, take a photograph, understand, can I land here? The data went back, it tackled with all the data that existed, and it said, no, you can't land here. You have to park your vehicle somewhere else. And this is where a lot of data has gone into it, a lot of decision making has happened there. The way I do, the way I do my car in a parking lot, exactly same thing happened over in Chandrayaan. AI machine learning was a very integral part. Although the entire rover lander was made by mechanical engineers, 4-bar chain, right? The force analysis, the temperatures maintained over there, all this done by mechanical engineers. At the same time, they all did the job of having machine learning, deep science into it, and take a decision as one would do, like if I'm driving a car. And this is where I feel the Chandrayaan 3 descent phase was fully automated. It does not include any human intervention. People were sitting down. They were not taking any decision. It was the rover itself was taking a decision whether I should land at place A, place B, place C, or whatever. The Vikram lander packed several sensors, including few camera sensors. They had a lot of videos. It compared with the old data that it had. If it tallied, no, it doesn't tally, go ahead. It had all the sensors, and these all sensors were talking about the inclination, the deep holes, the velocity meter, and all those things. So you had all this laser inertial referencing accelerometer package, lander position detection camera, lander hazard detection and avoidance, laser altimeter, laser Doppler velocity meter, and lander horizontal velocity camera. These all cameras enabled and plenty of sensors. Actually, we got a library of that thing. It compared with the whatever it had learned, and accordingly it took a decision. The way exactly I would take a decision to land to park my car in a simple parking lot. So this is very important that a decision has to be taken based on whatever data it took. And now next time, whatever it saw there goes to the library. So next time it becomes more intelligent. The library goes on adding, getting added, and become infinite. And that helps in decision making, further decision makings. This is exactly what happened. And you can imagine, as somebody pointed out, all these top bosses were mechanical engineers. If those mechanical engineers close to 60 could take all this decision to embed AI and ML in the decision making that it had, all of us have to change. So how did it happen? The evolution of AI ML. It happened right in 1955, where artificial intelligence started making a buzzword. In fact, I remember in 1978 or 1980, one of our Nagpur alum from our school only started working on artificial brain at IIT Bombay. It was his PhD topic then in computer science department. Around this time, around 1990, started machine learning business. This is all algorithm because the computers start coming and intelligent computation started happening. So machine learning became very important. Genetic algorithm came, and then we had deep learning, where you got so much of data now. What do I do with the data? So you can see that all this chain event and the fantastic computation system that we have today have enabled us to come to a proper decision that a human brain would otherwise take. So this is all started from the artificial intelligence, which basically nothing but is creating smart machine to mimic humans. So this machine should actually be better than a human, or at least be equal to human. And very small decision in microsecond that we try to think could be taken by this machine. So artificial intelligence has a subset of machine learning, wherein you understand that it builds a model based on training data to make predictions. So got to have a lot of data. I got to understand that, yes, my car can go here and there, but I got problems over here. I have to understand that thing. For further making decision, I got a deep learning. Today we got a CFD analysis. I'm doing a lot of CFD analysis, computational fluid dynamics. There are 4 PhD students I'm guiding only on CFD analysis to understand the velocity pattern, the airflow, and things like that. But one model works for 30 days. Then I get small reason. And then I understand, no, it is not meeting the convergence I wanted. So I go back and change my meshing and come back. which is huge. I can't have any decisions making done on this. So can I deep learning, which takes data and manipulates, and whatever data I otherwise take in 30 days can possibly taken in 3 minutes. And that's a very important matter. Can I take a fast decisions? So I got artificial intelligence, machine learning, deep learning, and to be supported by data science. And today, data science can handle huge data, can play with data, can find pattern in data, can actually, once you give a pattern, it can actually generate its own data. So that it has understood the pattern now, it can generate its own pattern. So this has become such an intelligent thing now that if I know that particular machine is failing every time, I just capture all the data and I understand now why it is failing. What is the pattern in that? Every 7 days, I get failure. For example, I will never possibly understand this reason. But if I got the data will tell me that there's a machine failure happening every 7 days, or the machine failure is happening between 1 to 2 o'clock every day, or the machine failure happen between 5 and 6 when the voltage drops. I can relate all these parameters to the environmental condition. Then it actually hunts for a pattern. So that pattern making is very important, which is called a generative AI, and I'll come to that little later. So data science is a subset of AI. It is an area of statistics, scientific method to extract meaning and insight from this data. So you see, all this together becomes your artificial intelligence machine learning. Nothing different. What we used to do, what we normally do, what we normally think as exactly same thing is being done by now, the algorithm. And ultimately, the human beings are the one who will actually create this data and feed this data into this. Industry is very important and industry is changing. Industry 1.0, 2.0, 3.0, 4.0, as we know, this is all about it. Industry 3.0 was automation, computers, and electronics, which happened around 1970s or 1980s. But Industry 4.0 is what we are talking about: cyber physical system, IoT, sensors. All right. And now we have got autonomous robots, simulation, system integration, IoTs, cyber security, cloud computing, additive manufacturing, augmented reality, and big data. All this combined is basically have your Industry 4.0, and Industry 4.0 is basically the AI associated with all these things. So we have to learn all these things that are happening into industries. Now I'll give a few case studies where mechanical engineers deal with AI ML on different cases. So AI is a trained system that can mimic human intelligence. Machine learning is an application of AI that allows machines to learn from data without being programmed explicitly. And the machine improves its own performance by learning the ways using which human seems to repeat. And ultimately, the new part in this also is coming natural language processing. I don't have to program C++ language. Somebody writes a program, I will never understand his C++ program. So can I speak in my language? Can I speak in my Hindi, English language? And the machine itself will now convert that the way it wants, the way it understands. So natural language processing, what we call as LLPs today, large language programming, large language models, they understand everything the way you speak, except that it has to get used to the way I speak, my pronunciation, for example, right? So if I teach the computer that this is the way I speak, after some time it starts knowing me very well. And whatever I speak in a car, I can say that put this song. This language can be converted and continuously, correctly, that song can be played now. It is actually converting my language. And Alexa, of course, all these things are getting transformed to a binary language which the computer understands, and actually it can hunt out a song which I want to hear. And this is nothing but what we are seeing. I'm playing chess every day on flight. Wherever I travel, I play chess. The chess has become more and more intelligent. I just have to choose the intelligence level. How does it preempt what I'm going to pay? Every time it knows that I'm going to, I take 10 minutes to make my one move, while the computer plays within a second. These are all becoming intelligent now, and possibly at one point in time, we'll have to make sure that we become intelligent also as well. So how does it work? We talked about everything. How does it work? The left side is absolute data. The data is the most important. The data can come from experiments. The data can come from simulations. But simulation cannot run like infinite times. I, of course, can get simulation done. The data collection can happen, pre-processing can happen, and I can actually create a database. In industry, I can create a database not for failure every time. How many times failure will happen? For years together, you get a normal data. And therefore, I can possibly simulate those failures and feed into data. And this data can then be fed to all these neural networks, all these algorithms that are available, to the genetic algorithms or different types of algorithms. And there are several algorithms. I will not go into details of that. There are specific expertise available into this. But then I got models. I work on these models. I work on physical mechanism model where I solve differential equation. I do meshing, I do CFD analysis, I do numerical analysis, and predict what will happen if the pressure increases, if the temperature goes down, what will happen, how the machine will fail. Will there be a lot of thermal stress? Will my pressure exceed the value at which it is designed? The machine will fail otherwise. Then I got a data-driven model now. So some data could be given. And the third one is hybrid. I can give data, I can give a CFD model. It can learn by itself. All these things I am doing basically, and they will talk to each other. All these things I am doing to basically do some optimization, to do some prediction, to do some classification, and based on which I can actually generate a lot of parameters, physical processes parameters, quantitative analysis, qualitative analysis, and things like that. So this is all it is. Data, I got algorithms, I got models, I got some verification of models also have been done with the actual systems, and accordingly, my end target I have got to decide. I would like to reach, for example, from here to airport in let's say 2 minutes. What are the possibilities? It can tell me. It can tell possibly that I should take an air taxi tomorrow. Air taxi is getting available now. So all these things can be available provided the data related to air taxi is made available to them. Then it will take otherwise, and today GPS is there, of course. You actually can take a route the way you want, fastest route, good route, whatever. I want to go via Dantoli, for example. Here I can take my decisions accordingly, and accordingly fastest route, optimized route, good roads, I can actually make optimization of those things. Similarly, prediction, what will happen after 1 year? When will my next failure be there? When will the machine fail? Why would the machine fail? What is the reason for that? All these things I can understand provided I got such data made available to me. The AI in CFD is very important because this is what we are struggling a lot right now. We got a huge model. I got a good combustion model. We are working on modeling of, for example, cryogenic engine combustion. Huge model, how the combustion will progress and how it will hit and the pressure we will transfer. For solving some 2-second case, my computer takes a lot of time. 2-second case. So AI algorithms have become very, very effective tools. And I don't have to really do entire machine now. I just run for some time and feed in data to it. I can immediately get convergence. So currently there are 3 typical AI CFD coupling models. The popular data-driven model techniques are large database. When the flow is complicated, CFD data are input into a machine learning model and directly can predict. So you can see that I go to meshing, I got a CFD, but I can do predicted value very fast in between. I think the laser here doesn't work. So AI accelerated CFD model. You can see the left one is a figure of CFD and the right one is a figure of AI assisted CFD. So right one I can run in 3 minutes. The left one will possibly take 2 months. And here plays a very important because I've got some data which is made available and then I can actually develop my CFD models. This is again something I'm working on right now. So I got a transport trucks and I work with a low temperature cooling business. And there's a refrigerated trucks which move 700 kilometers per day, and they take ice creams and fruits and everything from, let's say, near in middle Maharashtra, middle some Jalgaon region, and possibly come to Pune and Mumbai to deliver in DMart and Hycos and so on and so forth. So here I have to worry about temperature distribution in the refrigerated truck. If I put ice cream which has to be maintained at -30, I know a particular location. But the moment the airflow pattern changes inside, the temperature changes. So if I put different boxes at different places, the temperatures vary because the airflow pattern is governed by the location of heat exchangers, the location of blowers, and so on and so forth. So if I put a big box in the center, it changes the entire temperature distribution. And this is where I would like to understand what will I do if I place it here, if I place it here. All this data, I can run a small simulation. But if I do this experiment in one day, I can generate a lot of data. And this data, then coupled with my CFD model, can give fantastic results. I know I should keep ice cream at -30. I know vegetables need to be put at +10 degrees centigrade. And I know various locations now. I don't have to run a CFD model every time. I know all these locations. But the moment I change it, tomorrow the ice cream order has become 10 times more, my airflow pattern will change suddenly. But now the model can assist me to tell me that I should keep it at this location, and then the ice cream will be maintained at minus 30 degrees centigrade. Everybody knows driverless car. This car essentially completely an example of artificial intelligence and data science. It has got all the data of the road. And believe me, it will never meet an accident today. The kind of microsecond it reacts to. It actually looks at every possible places in the vicinity of it in as a function of its velocity, its speed. And corresponding, it can make very, very fast decision. It looks back, it has got two cameras, sensors, stop, everything. And this driverless car actually is an essential thing today. Self-driving cars are artificial intelligence to make real-time decisions based on the data they gather from their sensors. AI technologies power self-driving car use vast amount of data from image recognition. So image recognition, image construction, pattern making is a very important thing. Neural networks are that core here, and the data includes all kinds of camera and the data that is given. It actually knows street signs also. It will actually know that suppose the signage is at fault today, it will actually make a call there that your signage is not making because your rate to yellow is taking so much microsecond more. It has changed because it has got data of so many days. It can actually give a signal back that your signaling system is failure because of some reasons today. So all this data can actually be made available to this. See, data center cooling is a very important thing today. All these big giants, ultimately our data is to be kept at certain temperatures. So I'm working right now with SIDAC, where we got a Param computer and all that thing, where we are actually doing electronic chip cooling, and huge importance to this data center cooling. So and again, the system, the chilled water that we are working on is varies temperature plus minus 5. Plus minus 5 can make a huge difference sometimes because it is again having an airflow pattern and things like that. So again, I have got to, such a huge system if I want to maintain. And you can imagine a Google center. This is Google center. You can imagine a lot of data is sitting. Amazon, a lot of data is sitting down there. So I got to know about the blower speed if it is changed, or one particular blower in a system actually is not functioning today, it can make a huge impact. So this data is very important that something is not working. Accordingly, what my temperature distribution will be there. So the flow patterns, temperature flow, all these things, if I were to solve all this using a CFD analysis, no, it's not possible. It has to be AI assisted then. Otherwise, of course, you can publish a fantastic paper, you can get a best paper award, but it will not work. Nothing will be earned if I want to really give this solution and implement in practice. And that is what our objective has been. We are talking about manufacturing, mechanical engineering, huge concern on manufacturing in the AI data science. The robotics is very playing important role. 66 robot is getting one car out in 10, 15 minutes. Can you imagine 1,000 cars being assembled every day and they are coming out and still there is a waiting list. So robotics is playing a very important role. Companies like Amazon, you got an order and you got robo that your object is sitting on the top floor, second three row and third line. It has to go there, pick up the thing and pack thing for you to be sent to your houses. The warehouses are huge. If you go to Bhiwandi in Pune, in Mumbai, you can see the warehouses size 10 times bigger than this place. If I say I want a particular machine, now coffee making machine to be delivered to me, it has to actually locate immediately where that coffee making boxes are maintained. It should go there, pick up those boxes of the size or the number that I'm going to talk about, bring it back, pack it, and to be sent to my house by the evening of the day. And this can happen if you place an order today. I can get a coffee making machine tomorrow in my house in Mumbai. So they're all basically governed by all the database that has been created. It will walk, it will go to the third row, fourth column, pick up the coffee machine, pack it, and give it to you immediately. You know how many people work? 2 or 3 people work here. But most of the things are programmed very well now. So AI in manufacturing is playing a very important role in quality control. So quality control is a huge aspect. So again, we have to decide, the mechanical engineers have to decide what is your quality that you want. See, I'm not saying that role of human has gone. No, I have to define my standards. I have to say that tolerances between this is plus minus 2 microns. I have to define my tolerances, and accordingly, once I define quality, the AI, ML, all these programs will take a decision accordingly. But it is me who will basically decide what kind of quality I want. So quality control is very important, where I can actually see with a vision, I can see to a very plus minus 2 micron levels also. Semiconductor industry is going to be very important for mechanical engineers also. Chips are very important. Manufacturing has to be done again by us. Predictive maintenance. This is a very important thing. For example, in Tata Motors, you got so many engines coming out. All right, but then at particular machine, there's a problem today. There's a chatter. Somewhere a chatter is happening. I have to worry that this chatter today possibly will result after 30-second day. There's a problem here. 30-second day I'm talking about. That today on a chatter noise and the vibration level I see down there, I should be able to relate that vibration, today's vibration level, that this machine will not work beyond the 30-second day from today. Can you do that thing? Yes, it can be predicted as close to this as possible. Can we implement this? That's the problem. So now we've got a cobot also. I'll come to that thing. Yeah, AI in healthcare. If I come to now, away from mechanical engineers, I got a healthcare also, where all these industries, including diagnostics, including image processing, huge difference it will make, because again the data science becomes very important. There are various startups coming in this field, and we are hosting 1 or 2 startups who are actually doing image processing. And you don't have to do with X-ray. I don't have to do MRI now. Many times MRI, the costly MRI may not be required to be done if I got a good X-ray. So you can see the right side is a fantastic drawing. It's a AI assisted MRI now. The left side is proper MRI machines photograph, but the right side is such clear that I can actually take a very simple thing and AI assist. So I can take a 1.5 Tesla machine and the result can be equal to 4 Tesla machine. I don't have to buy 15 crore 4 Tesla machine of the MRI. 1.5 Tesla is good enough because my data becomes much more granular now. I got a signal that I have to go faster, so I'm trying to go a little bit. AI in aerospace, I think everybody can rely that everything on the ground can be taken care of, but in everything on the sky, you have to be very careful because somebody's life is at stake now. Can we take such issues? Ultimately, you say that everything is sort of subject to some probability here. So something is based on the data. What happens? You are the odd person where the data is not fitting correct. This can happen, right? Virat Kohli's last overs, 16 runs. Possibly no data would have said that he would have made these 16 runs in that last over because there is no data of this kind. AI would have failed actually there. But yes, he could make that and we could win against Pakistan. Similarly, if I am sitting in a flight, I would not like subjected me as a data point. I would like to be governed by proper equations, solve the CFD model, and get me result. But I should not be the data itself now, right? A wrong data possibly. Yes, so therefore one has to be very, very careful about AI stress. I think everybody has heard this term called digital twins. So this is going to be again for a big companies, digital twin is going to be making a huge difference. So I got a physical asset down here, but I got a digital twin. I got a complete factory here right now. I can do everything what I want with a digital twin that I have here. So this is my laboratory, one of the machines in my laboratory, and this is liquid nitrogen plant. We produce around 120 liters per hour. And this machine right now, I'm converting into a digital twin and actually artificial intelligence. I got a huge data. We do our own maintenance also. I got 2 engineers who actually maintain these machines, and we produce minus 196 degrees centigrade every day. Take the air and liquefy nitrogen. And I convert that to my digital twin here. I have converted every small little operation, and I can sit in my room, which is let's say 100 meters away from this lab. But I know all the parameters, all the pressures, I know all the temperatures, cooling water temperatures, everything I know. The moment it exceeds a particular level, it gives me beep, it gives me a red tone there. And moment I get that thing, I will ask my engineers to be careful about this. So this is what we are doing right now, and I got I'm plotting all the graphs. And the moment I hit a wrong note, I get a beep. Moment I know that these vibrations have gone up, I got accelerometer sitting down there, I got temperature sensor sitting down there, I got pressure sensors, and they're all actually getting plotted for every second. May not be every second, but maybe every hour. These machines work 24 hours by 7 for the entire year. And I'm buying right now 40 crore machine for liquid helium plant, which produces 4.2 Kelvin temperature. So you can see they're very important. They are very, you have to maintain this machine. I have to do predictive maintenance also. I don't want to wait for any breakdown to happen. I just want to mention this. We have just produced Indian MRI system, which is not yet launched. Some of you may be aware of this thing. 9 institutions have come together. The Ministry of Electronics have given a lot of funds, 200 crores fund. It will be launched somewhere in the coming months' time. This is Indian MRI machine, which will cost 2 crores as against 6 or 7 or 8 crores. Now, this MRI machine has to be integrated. Our next project is to integrate this with artificial intelligence and data science. Because still, we don't have in tier 2 and tier 3 city our own MRI machine. We still are buying from Siemens and GE. We are dependent completely on them and they sell it at any cost. Most of the doctors in Nagpur have a second-hand MRI machine because we can't afford the original MRI machine, which costs 10 crore. Otherwise, I have to pay 20,000 for one MRI today. But can it come down to 5,000 rupees? Yes, we can. But AI ML is going to play a huge market. And all these Siemens and GE are looking at India now, Indian engineers, to make a difference because they don't have any AI ML engineers today. So they're all coming to IITs that they want to give this project to us. Can you do it for us? So it is people like us basically who will make difference for others. Why not to make difference for ourselves? Where the mechanical engineers can play a huge role. Indian Railway, Kumbh Mela. I know there's one wrong person in could be there. I just can football match, cricket match. I can actually see the impression of everybody's face and can make out this man is dangerous. I can make out. The AI can actually see the expressions on your face that these are abnormal behavior. This man is behaving very randomly. It can find 5% in a crowd of 1 lakh people that these people are behaving not normal. Can I go and pick them up to see if they want to cause any trouble? There are such places where all these things can happen. This woman is talking one language, Spanish language, but her lip reading, I'm possibly deaf. I can actually convert her lip reading in the language that I understand. And the LipNet now is there. And we have created so much of hours of conversion of their lip reading now to any language, whatever language you or me want to understand, convert that. Google Translator is already there now, but can we do the lip reading now? So that somebody can just do lip reading and a deaf person can actually understand in the language he or she understands. Very important, very prominent. The retinographic, if I got a data of 10 lakh people, forget 10 lakh, if I got a data of 1 lakh people, 1,000 people, with the image of retina, I can make out everything. I can make out all the health history of a person. For example, the first one predicted age. The sex was female, female, non-smoking, non-smoking, HbA1c, diabetic or non-diabetic, BMI, blood pressure, heart, everything can be related to the retina now. So I just need to some retinal inputs from some person and possibly do all the checkup of a person, including cardiology, can actually be done by this. But I should have those data of those points who have got heart problems. Can I get their retinal input and compare this retina with all those things? And immediately it can tell me a lot of things. And this is not going to be very difficult, possibly in a year's time. I just need a retinal input from somebody. What is common in all these people? I got a data of 1 lakh people. These people actually are completely new people who never exist. Taking data from these 1 lakh people, I have created all these people who never exist. So if I know 10 lakh people, if I know 1 million people, if I know 10 million people, I can actually, the AI can actually build up a new face which will not be same to anybody else. So tomorrow in our film industry, you can possibly see a hero who never exists. But you can see his or her film and will possibly admire those people who never existed. And that's not going to be distant dream again. And there are super movies now these days where people never existed. So we can have tomorrow, forget the Khan and everybody, but we can possibly have a hero who never exists. Because, I can get everything done by these people, the movie and the fighting and everything can actually be done by such people and not a distant thing at all. AI in US is changing very fast. India is little behind. You can see that the market of 13.4 billions today can actually go to 223 billion by 2029. And all these big companies, Amazon, Google, Microsoft, Nvidia, Facebook, Intel, Rocket Fuel, they're all making a difference. Samsung, Lenovo, and all that thing. Machine learning, natural language processing are very, very important. We are catching up with all these people, but yes, we have a lot to do. I've got some Indian market also. Today, our market is very small. We are possibly at some 10 billion. Can we reach 75 billion at least? Can we reach 70 billion? When all our engineers are working in US company and making exactly the same. So can we do that in India? Yes, it's possible. In fact, a lot of things are changing. And yesterday only I understood that Government of India wants to create in every IIT and NIT is a very, very big AI/ML center. And this is all going to be coupled with all the engineering branches, not only to mechanical, but all the engineering branches. When I am doing all these things, when I'm mimicking all these people, ethics come into picture again. Ethics will play a very important. What should be done, what should not be done. So again, I will talk about AI ethics, but I will skip this right now. The data privacy is becoming very important. All right. So these are all summing up. These are new problems in mechanical engineering, which are basically hydrogen as the fuel, fuel cell, semiconductors, quantum computing, climate change, renewable energy, healthcare. These are all going to be coupled to AI. We are all working on these problems. We got a big hydrogen center at IIT Bombay. We got a big fuel center group, climate control, carbon capture, utilization, semicon, quantum computing. They all have to be coupled now to AI. Yes, we have to worry about those things. Coming to the last very important slide, opportunities for mechanical engineers. AI cannot replace human expertise at all. It is human who is creating this artificial intelligence. So mechanical engineers have to be there. They should come up with innovative idea and develop a unit accordingly. Mechanical engineers should design system with integrated AI. So all I was doing with a gear and a program, can I develop a machine integrally with AI itself? And this is where I needed training. This is where the institute like VNIT and IIT should change. And we have to start teaching at least one of the coursework in mechanical engineering as AI controlled mechanical engineers. They should analyze data generated by this team, create solutions, and innovate. The future of AI in mechanical engineering is promising. AI-powered machines are capable of performing tasks are beyond human capability, like predicting future outcomes. Mechanical engineers can work in a wide range of industries, including automotive, aerospace, manufacturing, robotics. With the integrity of AI, they can work in creating intelligent system for all these things. Various questions to ponder for us. Is AI a threat to mechanical engineers? No, it is not a threat at all. Only thing we have to wake up and we have to actually get trained on AI, assisted mechanical engineer. Would people lose jobs? These are the normal questions which were asked when electronics came into picture. Nobody loses job. In fact, more jobs will get created. But we have to modify, we have to train ourselves. Is AI a skill or a profession? I think I am sure all of us should ponder on these topics. AI systems are reaching tremendous size in terms of computer power. So AI system, one of the bad aspects of this carbon capture, because big data, big computation, big water, and therefore carbon. So all these are going to be little climatic thing, mass surveillance backlash, issues like CO2 emission, high water and power consumption. AI evils are also there. AI enabled crimes will increase. I can actually start doing all the backlash, surveillance, everything. Driverless human terrorism activities, one has to worry about all these things. AI enabled crime of moderate concern, AI enabled low concern. Burglary can happen. I can actually send somebody well trained. I know the entire map of your house or somebody's house, and he can actually go there and pick up something. That's that is not impossible. With this, where are mechanical engineers? Ultimately, our branch is such that it never will have an existential problem. We're all stabilized in the solar system, actually speaking. But in every solar items, as people start coming, the interface will get created and we have to change ourselves. We'll be actually all the stable, all the more stable, provided we actually have this flexibility of absorbing everything. So we have to be the in this solar system, we have to be there. But then our curriculum has to correspondingly change. Now the question is asked in our IITs, like how many subjects I should learn? Mechanical engineering as is expanding, how many system I should learn? Do I learn these things? I cannot learn all these things, right? This is too much for me. So I should actually find out, and every branch should actually find out what is correct vitamins for me, what is correct protein content for me, all right, and what is my weight. So my balanced diet is the most important thing. So balanced mechanical engineering, balanced operations, balanced training is the most important and the crux of matter. So I should have correct proteins, correct vitamins, correct minerals, and correct carbohydrates, sorry. So this is what I should have. And lastly, I'll end with this note that one machine can do the work of 50 ordinary men, but no machine can do the work of one extraordinary person. So I think I'll stop here and thank you very much. I'm sure they will not let me.
Thank you, Professor Atre, for sharing your profile insights into the role of AI and ML across all the domain. For most sitting over here having a background of mechanical engineering and considered AI ML as the most difficult topic to understand and further to implement. But I hope with Professor Atre's talk will definitely motivate most of you to take an application in mechanical engineering with the help of AI and ML, and also the way in the simplicity in which he explained the application of AI and ML across all domain signifies that how excellent teacher he is. So once again, a very big hand of applause to Dr. Atre. Yeah. Now, even though the miles may physically separate us, the power of technology brings us together through the virtual platform. It is an immense pleasure to welcome Professor R.P. Mohanty. R.P. Mohanty is a distinguished figure in academia and industry with a wealth of education achievement, including a PhD in mechanical engineering and honorary DSc degree. Professor Mohanty currently serves as Chief Consultant of SOA University following the tenure as its Vice Chancellor. Beyond academia, Professor Mohanty has provided invaluable advice to over 25 major companies, both in India and abroad, in the area of engineering and management. He has successfully led various government and industry sponsored research projects. Over his 46-year academic journey, coupled with a decade of top tier industry experience, Professor Mohanty has authored 17 books, published over 350 research papers in reputed international and Indian journals. His guidance has shaped the work of 28 PhD scholars and numerous master theses. Without taking much time, I would like to invite Professor Mohanty to deliver his talk in an online mode.
Am I audible to the audience?
Yes, sir. You are very much audible. Thank you.
Okay. Thank you very much, madam, for introducing. Visitors are in the meeting.
Yes, you are audible, sir.
Yeah. So I.
Yeah, it's fine, sir. Hello.
Okay. Let us go quickly. schemes for our faculty members, whether they may belong to mechanical engineering or civil engineering or electrical engineering, computer science or any branch of at least today, some it is our statics and dynamics, strength of materials and mechanics of solids, materials engineering like composites, nanomaterials, etc., thermodynamics, heat transfer, energy conversion, fuels, combustion, internal combustion engine, like including fluid statics and fluid dynamics and computational fluid dynamics, like etc. etc. Mechanical, machine design, kinetics and dynamics, instrumentation manufacturing, vibration, control engineering, hydraulics and pneumatics, mechatronics and robotics, engineering design and product design, drafting and computer design and computer manufacturing. My question is, Professor Atre was mentioning very briefly about this. How many things a student can learn? But you see, mechanical engineering as a discipline started with what? One Newtonian mathematics. Newton, Peterson, Nietzsche, they were promised to be the greatest. But when Nicholas was a mathematician, he promised his paper in those days to other people easily. But what is the result? What was the result of the people's calculation? Yes, the calculation. Levin said no. We can't teach everything, but the fundamentals are being fundamental. I know as a student of engineering, I studied seven papers in mathematics. Seven papers in mathematics. All mathematics mathematics, starting from not only from geometry or promoting the concept research. Multidimensionality constraints.
Thank you, Professor Mohanty, for sharing your profound insights about the wide scope and prospects of mechanical engineering. Your wisdom and foresight are truly inspiring for the participants, especially from the academia, to come up with Industry 4.0 lab to cope with the industrial revolution at present day. I would like to express my gratitude to both our distinguished speaker and to all of you in the audience for your participation. Once again, thank you all for joining in this enlightening session. Uh, we now invite you for the post-lunch session after the lunch break, where you can continue your discussion and networking with the fellow experts in the field of mechanical engineering. Okay. We look forward for more engaging sessions throughout the convention and seminar. Have a wonderful day. Some instruction from organizers.
Thank you, ma'am. Friends, we're already running late, and therefore, our request from our end, kindly finish up your lunch briskly in about 20 minutes time and be back here at about 2:30 or so. Thank you very much, friends.
Thank you, Rakesh. Thank you very much for inviting me.
Namaste.